Alright, welcome to the second video in the electrostatics series. In the last video, we talked about how things can become charged. In this video, we're going to start the math behind it. So before we begin, we need to talk about what units charge is represented in. So charge is going to be measured in a unit called coulombs, and coulombs has the capital letter C as the unit. Now, the total amount of charge on an object is going to be represented by the lowercase letter q. And so whenever you see q, that is the variable for charge. So q is the variable and c is the unit. So just like if you were to say, what's the variable for velocity? Variable for velocity is v, but it's measured in meters per second. In the same way, the variable for charge is q, and it's measured in coulombs. Now, in the last video, we reviewed and talked about a proton and an electron. And if you remember from chemistry, protons and electrons have the same charge in the sense they have the same magnitude. So we would say if you have one proton and one electron, then it would balance out to be zero, and that is correct. Now that we're talking about charges in terms of coulombs, we need to know what that charge is. So the charge of a proton is going to be the exact same thing as the charge of an electron, only their signs are going to be different because protons are positives and electrons are negative. And that charge is 1.6 times 10 to the negative 19th coulombs. Now that charge is on your formula sheet that you were given, so you'll never have to memorize that, but hopefully by the end of doing some practice, you'll have it memorized just because you will have used it so many times that you just know it by heart. But the charge of a proton and electron is 1.6 times 10 to the negative 19th coulombs. Now you'll notice here that there is a scientific notation, and it's been a while since we've done scientific notation. So before we begin, I'd like to do a little review of your calculators and how you do scientific notation. So let's say you are doing the math here and you need to punch in your calculator the number 1.6 times 10 to the negative 19th. Okay, so 1.6 times 10 to the negative 19th. Now, how do you punch that in your calculator? It's very important that you make sure you do it the way I'm telling you, because there's a lot of ways students do this, and if you do it wrong, you'll get the wrong answer, not because you don't know how to do the problem, but because you just punched in your calculator incorrectly. So I have on the screen here probably the 4 most common calculators I've ever seen. If your calculator is not shown, I do apologize, but I'm hoping with what I show you, you'll be able to figure it out on your calculator. So most students have a graphing calculator, whether it's a TI-83 or a TI-84 in this case. And so for you, what you're going to want to use is you're going to want to use this EE button right here. Okay, so you notice the double capital E. And so when you're punching it in your calculator, you're going to hit 1.6, and then instead of this times 10 portion, what you're going to do is you're going to hit the second button, and then you're going to hit the comma so you can get the E. And so what'll pop up is it'll pop up in your calculator 1.6 capital E. That capital E stands for times 10, and then all you have to do is type in to the negative 19th. Now make sure you hit the negative button, not the subtraction button. So the negative button, it's not shown on the graphing calculator, I apologize, but it's typically going to look something like this, a negative symbol inside of parentheses. On this calculator, there's the negative, and then on this calculator, there's the negative there. So you don't want to hit the subtraction button, but you want to hit that negative button. Now, let's say you don't have a graphing calculator, but you have this second calculator. It's a TI-30X. And so what you're going to do is you're going to hit the 1.6. So 1.6 right here, 1.6. And then you're going to hit the same, it looks very similar. It's the second button, and then your EE button is right here. And I'm sorry, I'm in black ink, so you can't really see that. Let me change ink colors here real quick. Let's see if red pops up a little bit better. There we go. So you're going to hit the second button. Oh, it went back to black. I apologize. Okay, so you're going to hit the second 1.6, hit the second button. There we go. And then you're going to hit this button right here. So you pop up that EE again. And it's going to be the exact same thing as the graphing calculator. And it is because they're both TI products. And so they have them programmed the same way. So it'll pop up 1.6. And then when you hit the second and then the EE button, it'll pop up with the E. And then you'll type in negative 19th and go on your merry way. If you have a Casio product, the last 2 are Casios, you're going to hit 1.6. And then for this calculator right here, you're going to hit the EXP button right down here. EXP. When you do that, it's going to ask you what the exponent is, just like before. you're going to hit the negative button, and then you're going to hit 19 for negative 19. So it's going to actually punch it in with a times 10 in the number. And then for the final Casio calculator right here, you're going to hit 1.6, and then the button you will hit is this one right down here, the times 10 to the x. Whoops, there we go. Times 10 to the x, and then it'll ask you for your exponent, hit the negative button, and then hit 19. Now, if you have this Casio calculator, you may have had the experience of it keeping everything in fractions, and you're wondering, why does it have it in fractions? I can't answer that question. I have no idea why it has it in fractions. I'm sure there's a reason. But the way you turn it into a decimal number is you hit this button right here, the S double arrow D button. If you hit that button, that will turn it into a decimal number. I know some students have those calculators, and they've always been frustrated by that. So if you have that calculator, it's an easy fix. Just hit that button, and it'll turn your fraction answer into a decimal answer. But that's how we calculate it and plug it in. So hopefully you learned something from that, and I apologize if you already knew that. Now let's get to the math for those that already know that, and let's get back on track here. All right, so let's look at our examples here. So I've got a few examples here. The first one, an object contains 4 more protons than electrons. Find its charge. So remember in the previous video, if you just watched that I talked about a neutral object does not mean that it has no charge, but it just means it has equal number of protons and electrons. So maybe it has 2 protons and it has 2 electrons. Okay, so that's neutral. But this is telling us an object has 4 more protons than electrons. So in this case, it'd be 1, 2, 3, and then 4. And so if we're looking at the charges, these charges cancel each other out, and so do these ones. They neutralize, but you end up having a net charge of 4 protons. And so what would be its charge? Well, we know that we're starting out with 4 protons. All right, and then I'm going to set up my conversion here. I know that for every 1 proton, it has a charge of 1.6 times 10 to the negative 19th coulombs. All right, and so when I multiply that all together, the protons will cancel out, and I will be left in coulombs right here. And so let's do that now in our calculators. This is going to be our first test to make sure we know how to punch things in using scientific notation. So I'm going to do 4 times 1.6, and then you're going to want to hit whatever button I told you to hit at this point. If you have a TI, it's going to be that double E. If you have a Casio, it's going to be the EXP button or the times 10 to the X button. So I have a TI 83, and so I'm going to hit the double E, the second, and then the E button. And then I'm going to type in negative 19. Once again, make sure you have the negative symbol. And then I hit enter, and if I hit enter, my correct answer is going to be 6.4 times 10, whoops, there we go, times 10 to the negative 19th, and then coulombs is my unit of charge. Okay, let's look at the second one here. It says an object contains 3 less protons than electrons. Find its charge. So let's think that through real quick. It has 3 less protons. Doesn't matter how much it has total. All I need to know is that it has 3 less. So let's say a neutral compound, so maybe it had 3 protons, and then it had 3 electrons. So there's my neutral compound. But if it has 3 less protons, okay, something like that, then it's going to have a net charge of negative or 3 negatively charged particles, so 3 electrons. And so this time, I'm going to set it up with 3 electrons is how many I have in net. And then I set it up for every 1 electron that I have, it's going to have a charge of negative 1.6 times 10 to the negative 19th. Okay, because remember, electrons are negative. And so we're going to set it up in our calculators the same way as before. 3 times negative 1.6 times 10 to the negative 19th. And my answer for that is going to be negative 4.8 times 10 to the negative 19th coulombs. All right, last question here. It's being asked a little bit differently. It says, how many electrons would you have if you had exactly 1 coulomb of charge. Now, it doesn't specify it, but it is assuming that you can understand that that's going to be negative because it's electrons there. And so if something had exactly -1 coulomb of charge, how many electrons is that? So we're going to start out with -1 coulomb. All right, and then I'm going to set it up just like before, but this time I'm going to put the charge on the bottom. I know that for every 1 electron that I have, it's going to have -1.6 times 10 to the -19th coulomb of charge. I have to put coulombs on the bottom, so that way when I multiply through, the coulomb units cancel out. And so I'm going to do -1 divided by 1.6 times 10 to the -19th. And if you did that correctly in your calculator, your answer should be that you have 6.25 times 10 to the 18th electrons, which is a lot of electrons. But that makes sense because there's a lot of atoms in materials. And so if there's a lot of atoms, there's certainly going to be a lot of electrons as well. So you'd have 6.25 times 10 to the 18th electrons there. All right, let's do some more practice here. A coulomb is a very big unit of charge, and so it's not uncommon to be dealing with units of microcoulombs as well as nanocoulombs. And so a microcoulomb is equal to 10 to the -6th coulombs, and a nanocoulomb is equal to 10 to the -9th coulombs. Now, I believe that's given to you on your formula sheet, but I might be mistaken. So make sure you check that. It might be something that you need to memorize for a quiz or a test. So let's do some sample problems with those conversions there. So we have an object that has a charge of 5 microcoulombs. Find the number of electrons. So 5 microcoulombs there. Okay, and once again, it doesn't have the negative there. It's assuming you will know it has a negative charge. And so we have 5 microcoulombs. Now, we need to get this into coulombs in order that we can use our 1.6 times 10 to the -19th conversion there. And so this is the easiest way. Here's what I tell students. I say first things first, just write down the number itself. And so, and remember it's negative because we're dealing with electrons here. So -5.0. And then since it's micro, what does micro stand for? Times 10 to the -6th, right? So we just add that, times 10 to the -6th. And that's how many coulombs it would be. So 5 microcoulombs is the same thing as 5 times 10 to the -6 coulombs. And so now that we're in coulombs, we can now use my conversion just like before. There is -1.6 times 10 to the -19th coulombs for every 1 electron. And so if we multiply that out, -5 times 10 to the -6th divided by -1.6 times 10 to the -19th, we will end up getting my number of electrons is 3.125 times 10 to the 13th electrons. All right, let's do one more. Find the number of electrons that makes a charge of 20 nanocoulombs on an object. Okay, so once again, I'm going to start off with what I'm given. Since I'm dealing with number of electrons here, it's going to be -20.0. So we just write the number, and then what does nano mean? Nano means times 10 to the -9th. So we just add that on there, times 10 to the -9th. That's the easiest way to do it. And so now that gets me into coulombs. So 20 nanocoulombs is the same thing as 20 times 10 to the -9th coulombs. And so now we can use my conversion. There is -1.6 times 10 to the -19th coulombs for every 1 electron. And so multiply that out. -20 times 10 to the -9th divided by -1.6 times 10 to the -19th is going to give me my number of electrons, and I get 1.25 times 10 to the 11th electrons. And it looks like this does conclude our video. We'll see you in the next video for further electrostatics math.